Hello dear students, we are going to solve some numerical problems related to refraction through lenses. At first let us review the related formulas. First formula is lens formula, which is 1 upon f is equal to 1 upon u plus 1 upon v. Here f is focal length, u is object distance and v is image distance. All real object and image distances are taken positive and virtual object and image distances are taken negative. Focal length of convex lens, also called converging lens, is taken positive, and that for concave lens, also called diverging lens, is taken negative. This is second one. 1 upon f is equal to mu minus 1 into 1 upon r1 plus 1 upon r2, which is lens maker formula. Mu is refractive index of lens material. R1 and R2 are the radii of curvature of its two surfaces. Third, magnification, small m is equal to v upon u is equal to I upon O. I is the size of image, O is size of object. Power of lens in diopter is equal to the reciprocal of focal length in meters. When two lenses of focal lengths f1 and f2 are placed coaxially in contact, then the combined focal length capital F is given by this relation 1 upon f is equal to 1 upon f1 plus 1 upon f2. Now, problem number 1. A convex lens of focal length 24 cm and refractive index 1.5 is completely immersed in water of refractive index 1.33. Find its focal length in water. Solution to question number 1. Given for convex lens, f of glass is equal to 24 cm, mu of glass is 1.5. When it is completely immersed in water of refractive index 1.33, then we have to find its focal length. We have to find for convex lens, focal length f is equal to 24 cm and its refractive index mu g is 1.4. We have to find focal length when lens is completely immersed in water of refractive index mu water is equal to 1.33. Solution from lens formula for glass lens. One upon f is equal to mu glass minus 1 into 1 upon r1 plus 1 upon r2. Suppose this is equation 1. When lens is completely immersed in water, then 1 upon f dash will be equal to mu glass upon mu water minus 1 into 1 upon r1 plus 1 upon r2. This is equation 2, because r1 r2 remain same in both cases. Now equation 1 upon 2 gives f dash goes in the numerator. The f dash upon f is equal to 1 upon r1 plus 1 upon r2 cancels out, and we get mu glass minus 1 upon mu glass upon mu water minus 1, which gives f dash as f into mu g minus 1 upon mu g upon mu w minus 1, which is 24 into 1.5 minus 1 upon 1.5 upon 1.33 minus 1, which gives f dash as cm, which is nearly 94 cm. Question number 2. The question is, the image of an object is obtained on a screen with the help of a converging lens. The distance of object is 40 cm from the screen, and the size of image is 9 times the size of object. Calculate the distance of screen from the lens and focal length of the lens. Solution to question 2. Here given, suppose this is screen, this is lens, and this is object. Distance of object from screen is given to be 40 cm, and magnification m is 9, means I upon O is equal to V upon U. Therefore, V will be equal to 9U. We have to find the distance between lens and screen, means V, and we have to find the focal length. This distance is U. Now from this diagram it is clear that U plus V is equal to 40 cm. From figure, U plus V is equal to 40 cm, and V can be written as 9U. Therefore, U plus 9U is equal to 40 cm. 10U is equal to 40 cm, so U will be equal to 40 upon 10, means 4 cm. Hence, V will be equal to 9U. 9U means 9 into 4, 36 cm. So, U will be 4 cm and V will be 36 cm. Therefore, 1 upon F is equal to 1 upon U plus 1 upon V gives 1 upon 4 plus 1 upon 36. LCM is 36. 9 plus 1. 1 upon F is equal to 10 upon 36. Therefore, F will be equal to 36 upon 10, means 3.6 cm. Thus, B is equal to 36 cm and F is equal to 3.6 cm. Next question number 3. The question is, an object is placed at a distance of 30 cm from a thin lens of power 4 diopter. Discuss the nature of the image formed. Solution. Question 3. Here, power of lens is 4 diopter. Therefore, focal length will be equal to 1 upon P, 1 upon 4 means 0.25 meter, or this is equal to 25 cm. Therefore, 1 upon F is equal to 1 upon U plus 1 upon V gives 1 upon V is equal to 1 upon F minus 1 upon U. 1 upon V is equal to 1 upon F is 25, 1 upon 25 minus U is 30 cm to 1 upon 30. LCM is 750. 30 minus 25. 1 upon B is equal to 5 upon 750, which is 1 upon. Thus, B will be equal to 150 cm and magnification will be B upon U is equal to 150 upon 30 means 5. Thus, the image is inverted, real and enlarged or magnified. Question number 4. Question is, an erect object is placed at a distance of 10 cm before a convex lens of focal length 15 cm. Where will the image be formed? Discuss the nature of the image. Solution to question 4. Given for convex lens, focal length is 15 cm, object distance is 10 cm. We have to find the B is what and nature of image. Now, from lens formula, 1 upon F is equal to 1 upon U plus 1 upon V, which gives 1 upon V as 1 upon F minus 1 upon U. 1 upon V is equal to 1 upon 15 minus 1 upon 10. LCM is 150. 10 minus 15. 1 upon V is equal to minus 5 upon 150, which gives minus 1 upon 30. Thus, B will be equal to minus 30 cm. Magnification B upon U is equal to minus 30 upon 10 cm. Cm cancels and minus 3. Negative sign indicates that the image is erect. Thus, The image is erect, virtual and magnified. Next question number 5. An equiconvex lens has power 4 diopter. What is radius of curvature if mu is equal to 1.5? Solution to question 5. Given for equiconvex lens, power is 4 diopter. Therefore, focal length will be equal to 1 upon p, 1 upon 4, 0.25 meter or 25 centimeter. Also, for equiconvex lens, R1 is equal to R2 is equal to, suppose R, we have to find radius of curvature. Now from lens maker formula, 1 upon f is equal to mu minus 1, 1 upon R1 plus 1 upon R2, 1 upon 25, 1.5 minus 1 into 1 upon R plus 1 upon R means 2 upon R. This is 0.5 into 2 upon R. So 1 upon 25 is equal to 1 upon R, which gives R as 25 cm. So the radius of curvature is 25 cm for each surface. Next question number 6. Question is, the real image of an object formed by a lens of power 5D is 3 times the size of object. Find the object and image distances. Solution to question 6. Given power of lens is 5 diopter, therefore focal length will be equal to 1 upon p, 1 upon 5 means 0.2 meter, which is 20 centimeter. Magnification is given to be 3 times means 3, which is b upon u. Therefore, b will be equal to 3u. We have to find u and v. Now, from lens formula, 1 upon f is equal to 1 upon u plus 1 upon v, which is 1 upon u plus 1 upon 3u. 1 upon f is equal to 1 upon u taken common, 1 plus 1 by 3, which is 4 by 3 u. Therefore, u will be equal to 4f upon 3. 4f upon 3. 4f is 20 cm upon 3 means 80 upon 3 cm is the object distance, and from this relation b will be equal to 3u means 3 into 80 upon 3 means 80 cm. Thus the object distance is 80 upon 3 cm and image distance is 80 cm. Next, question number 7. The question is, a converging lens of focal length 5 cm used as simple magnifier produces a virtual image 25 cm from the eye. How far from the lens should the object be placed? What is the magnification? Solution to question 7 here given. This is thin converging lens of focal length 5 cm used as magnifier. As we know, in magnifying glass, eye is just near the lens. This is object. Object distance is to be found. The virtual image is formed. Virtual image is formed at distance d, which is equal to v is equal to minus 25 cm. This distance is 25 cm because eye is placed near the lens. This is eye. Now 1 upon f is equal to 1 upon u plus 1 upon v gives 1 upon u as 1 upon f minus 1 upon v, 1 upon 5 plus 1 upon 5 minus minus 1 upon 25. So 1 upon u comes to be 1 upon 5 plus 1 upon 25. LCM is 25. 5 plus 1. So u is 25 upon 6, which is nearly 4.2 cm. Therefore, magnification will be equal to, linear magnification will be equal to v upon u minus 25, and u is 25 upon 6, which is minus 6. Minus indicates virtual image. Thus, u is 4.2 cm and m is 6. The question is, the radii of curvature of the faces of a thin converging meniscus lens of glass of refractive index 1.5 are 15 cm and 30 cm. What is the focal length of the lens when it is completely immersed in water of refractive index 4/3? Solution. Lens maker formula is given as (1 upon f is equal to mu minus 1 upon r1 plus 1 upon r2). When the lens is immersed in water, then refractive index mu will be equal to mu glass upon mu water, which is 1.5 upon 1.33. 4/3 means 1.33. Also R1 is given to be 15 cm and R2 is 30 cm. Therefore, equation 1 gives 1 upon F is equal to 1.5 upon 1.33 minus 1 into 1 upon 15 plus 1 upon 30. This gives 1.5 minus 1.33 upon 1.33 into 30 is LCM, 2 plus 1 means 3 upon 30, which gives 1 upon F as question is, an object to the left of a lens is imaged by the lens on a screen 30 cm to the right of the lens. When the lens is moved 4 cm to the right, the screen must be moved 4 cm to the left to refocus the image. Determine the focal length of the lens. Given this is object. When the convex lens is at position L, then the image is formed on a screen at position S. This distance is given to be 30 cm. So, when the lens is at position L and screen at S, then 1 upon F will be equal to 1 upon U plus 1 upon B. 1 upon U plus 1 upon 30. Question 1. Now, the lens is moved 4 cm to right, means this lens has been displaced to position L dash and screen S is displaced to position S dash 4 cm left. So, in second case, when the lens is at position L dash and screen at S dash, then U dash will be equal to, this distance will be U plus 4 and B dash will be equal to, this distance means total 30 cm minus 4 cm minus 4 cm, to 30 minus 8 is equal to 22 cm. Therefore, 1 upon F will be equal to 1 upon U dash plus 1 upon V dash, means 1 upon U dash plus 1 upon V dash, which is 1 upon U plus 4 plus 1 upon 22. V dash is 22. This is equation 1. Equating 1 and 2, we get 1 and 2, we get 1 upon U plus 1 upon 30 is equal to 1 upon U plus 4 plus 1 upon 22. Therefore, 1 upon U minus 1 upon U plus 4 will be equal to 1 upon 22 minus 1 upon 30. So u into u plus 4 is LCM. Here we have u plus 4 minus u is equal to 330 is LCM of these two. So this is 15 minus 11. U cancels out and we get 4 upon u square plus 4u is equal to 4 upon 330. 4 also cancels out and cross multiplying we get u square plus 4u minus 330 is equal to 0. This gives u is equal to minus 4 plus minus under root 4 square minus b square minus 4ac. 4, a means 1, c means minus 330 whole upon 2 a means 1, which gives u is equal to 16.2 cm or u is equal to minus 20.15 cm. The negative value is rejected. Therefore, u will be this one. Now, 1 upon f is equal to 1 upon u plus 1 upon v gives, which gives f as 10.5 cm. The question is, a thin equiconvex lens of refractive index 1.5 whose surfaces have a radius of curvature 24 cm is placed on a horizontal plane mirror. When the surface between mirror and lens is filled with a liquid, a pin held 40 cm vertically above the lens is found to coincide with its own image. Calculate the refractive index of liquid. Solution. Here in this diagram, this is a horizontal plane mirror on which equiconvex lens of glass of refractive index 1.5, mu g is given to be 1.5, is placed. The space between mirror and lens is filled with a liquid and a pin held vertically upwards at 40 cm above the lens is found to coincide with its own image. Means when object is placed at this point, this height, then its image is formed at the same height. Then we have to find the refractive index of liquid, mu L. Solution. As it is clear from the diagram, this is glass lens and liquid also forms a liquid lens which is plano-concave lens. One surface of liquid lens has infinite radius of curvature and the other surface is getting its shape from the glass lens, but being concave, its value will be negative. So, we know the combined focal length of two lenses in contact is given by If capital F is the combined focal length, small fg is the focal length of glass lens and small fl is the focal length of liquid lens, then it will be given by 1 upon capital F is equal to 1 upon F of glass plus 1 upon F of liquid. Suppose this is equation 1. Again, if we see this diagram, if this point is the combined focus, then the ray passing from this point vertically downward will be incident on plane mirror at 0 degree, therefore will be reflected back. Again, any ray coming from focus will become parallel to principal axis, and again on the plane mirror it will be reflected back. Similarly, this side also ray coming from focus will become parallel and will be reflected back. Means this point will be the focus, combined focus, so we can write this as capital F. Now for glass lens, R1 is equal to R2 is equal to R is equal to 24 cm because it is equiconvex lens. So 1 upon F glass will be equal to mu of glass minus 1 into 1 upon R1 plus 1 upon R2, which is 1.5 minus 1 into 2 by R, which gives 0.5 into 2 means 2 into 0.5 upon R means 24, which is 1 upon 24. So 1 upon Fg will be equal to 1 upon 24. Now equation 1 can be written as 1 upon F liquid is equal to 1 upon F minus 1 upon F glass, which is 1 upon 40 minus 1 upon 24 is equal to 120 is LCM, 3 minus 5, which is minus 1 by 60. Again, from lens maker formula for liquid lens, 1 upon F liquid will be equal to mu liquid minus 1 into 1 upon R1 dash plus 1 upon R2 dash, where for liquid lens R1 dash is infinity plane surface and R2 dash is equal to minus R because its value is same as that of glass lens, but it is diverging, minus 24 cm. This is showing the diverging nature, concave. So 1 upon minus 60, this one is equal to mu L minus 1 into 1 upon infinity minus 1 upon 24 or plus minus 1 upon 20, 1 upon infinity plus minus 1 upon 24, 1 upon infinity is 0, this is 0, Therefore, minus 1 upon 60 will be equal to minus 1 upon 24 into mu L minus 1. Minus minus cancels out. 24 can be taken here. So 24 upon 60 is equal to mu L minus 1. This is 2 upon 5. So mu L will be equal to 1 plus 2 by 5, which is 1.4. So the refractive index of liquid will be 1.4.